Okay guys, in this section 7-10 we're looking at the product to sum formulas, and so you can see them here, and what it allows you to do is take a product of sine or cosine and separate it out as a sum or a difference in this fashion. There's 4 of them that we're going to be looking at, and where these come in useful is problems like these where it says to rewrite the product as a sum or difference. Alright, now for this first one, cosine 5x times the sine of 4x, then we can take these. The first thing we want to do is identify which formula applies. Sine, cosine, sine. Cosine, sine would be the last formula, so that's the one that we will follow when we go in and we fill it out. So this will be equal to, and then again, just following the formula along, it would be 1/2. Alright, then we've got sine, and it's going to be sine of 5x plus 4x, so that would be the u and the v. 5x plus 4x. Alright, and then again, continuing to follow the formula along, it's going to be a minus sine of, and once again, it's this time it's u minus v, so that's going to be 5x minus 4x. And so from here, it's just a matter of simplification to come up with our answer. We'll have 1/2. And so the next thing that we can do here is we can add 5x plus 4x and make that sine of 9x minus sine of 5x minus 4x would make x. And then there is your simplified answer. We have now rewrote the product as a difference, right? Let's try the next one. Now in this example, we've got 8 times the sine of 2x times the cosine of 6x. And here's one thing that we're going to do in order to kind of simplify things just a little bit. I don't know if you remember, but in 7-1, when I gave you all of these formulas and identities, down at the bottom we had the even and odd identities, and we just kind of glanced over them. We didn't really talk about them much, but these formulas allow you to take, if you're taking a trig function of a negative angle, and it tells you what it's equal to. So the sine of negative u equals to the negative sine of u, but then the cosine of negative u equals to the positive sine of u, and then so on. You can see what the rest of them are. Alright? Now, here's the deal. In this one, if I were to leave 2x as u and 6x as v, if I have a formula, and all of them, as you can see, have a minus in there at some place, so then I would be doing u minus v. If this number is smaller than this number, that subtraction is going to produce a negative result. Alright? And the way to rewrite that negative result would be to go back and look at one of these even or odd identities, one of these two. Right? Now, we can eliminate that step of having to go back and use these formulas to simplify this or this just by taking one step at the beginning to rewrite it so that the larger of these two values comes first. So I'm going to write this as 8 times the cosine of 6x times the sine of 2x. Alright? And so just by rewriting that before we begin, that's going to change the position of my u and my v, and it's always going to make the subtraction of the two be positive, so we don't have to go back to these formulas. Alright, so but if you don't do that, it will still come out to be the same answer. So just maybe a matter of convenience if you elect to switch those before you start or not. Okay, you'll come up with the same answer regardless. Alright, Let's see here. So from here, it's cosine times the sine, and so that's cosine times the sine. So that's once again going to be the last formula. We'll take it, we'll plug in. First of all, that's going to be half of 8, which is going to be equal to 4. So we'll make that 4. Then we will open a set of parentheses, and we'll go ahead and follow the formula along. It's going to be sine of 6x plus 2x. Formula in the middle there is a minus. And we'll go sine of 6x minus 2x. Alright. Then from here, let's see, what can we do next? We can go 4. And we'll go ahead and add these two together. Sine of 8x. Don't need a parenthesis there. Oops. Sine of 8x minus the sine of 4x. Alright, and that's as simple as we can get it. So as I said, by switching that at the beginning, it eliminates the need for one last step here to change this negative 4x to whatever it would be. You see what I mean? So again, if you don't want to do that, that's fine. You'll still get the same answer. You'll just have one more step down there to simplify to get to it. Okay? Alright, so now let's take a look at our sum to product formulas. Okay, so now we're taking sums and rewriting them as products. So it's kind of the other formulas in reverse. And so again, you've got 4 of them, and you can take a look at the form there of what it looks like. And these formulas come in handy when you're doing problems like this. It says find the exact value of the cosine of 195 plus the cosine of 105. Okay. Now, once again, we've seen problems like this before in this unit. What you can do is you can rewrite these as a sum or difference of values that we already have on the unit circle. And if I was trying to write 195, we could go over here and see if we could take a moment to see what two numbers on the unit circle would add up to 195. And let's see, just kind of going off and trying to think about it. You could find them, or perhaps not. Some may be able to be written as the product or difference of two of these. But then once again, some of them may not. It is possible that you wouldn't find a pair that would give you a sum or difference of this. So that's where these other formulas would come in. And so on this one, again, I just need to determine which one of the formulas I'm going to be using. So I've got cosine plus cosine, and so that's going to be the third formula. And so when I come to start filling it out, we're going to have 2 cosine, and I'm going to open a set of parentheses here, and it's going to be u plus v, right, which is going to be 195 plus 105, and we'll make all of that over 2. Alright, and then that's going to be times cosine, and another set of parentheses. Alright, and we're going to have u minus v this time. 195 minus 105, and it's all going to be over 2. Now, just like in the last problem that we had here, looking at these, it's probably more advantageous if you make that angle in here positive. So having the bigger angle here as the U and the smaller angle as the V would again eliminate that extra step of having to rewrite it as a using one of those even or odd identities to rewrite the negative angle out of it. All right. So what we could do is if the smaller angle comes first, just switch them, and then you'll be back in business. All right. Let's see. What else do I want to point out there? Yeah, the only time that potentially could be an issue is if this one's a minus and this number's bigger, then you would have to switch them around and to be negative of this plus this, which we don't have any formula for. So you may have to be careful doing that. But in any case, they're in the right position here now, which is good. And so again, to go through and finish that, we'll write this as 2 cosine. If I add these up, that would be 300 divided by 2, which is 150. And this will be cosine of, let's see, 90 over 2, which is 45. And then from here, we can go to our unit circle and get these values. Cosine of 150, let's see what it is. Here is 150. The cosine is negative square root of 3 over 2. All right, so we'll go negative square root of 3 over 2. All right, and the cosine of 45 is going to be square root of 2 over 2. All right, and so we can go through and finish this out now. The 2's here would cancel. Negative times a positive is a negative. Square root of 3 times the square root of 2 is the square root of 6. And then that's going to be over 2. And then there's your answer. All right. Let's try the next one. So here I need to find the exact value of these two added together. So once again, let's see what formula we're going to be utilizing. Sine plus sine is the very top one. And so when I go to write this out, we'll follow the formula out and call it 2 sine. And we'll open a set of parentheses. So it will be 2 sine of u plus v over 2. So u plus v over 2 is going to be 5 pi over 12 plus pi over 12, right? And that's all going to be over 2, so we've got fractions over fractions. We always love when that happens. And we'll have cosine of, and again, following the remainder of the formula here, cosine of u minus v over 2. So that'd be 5 pi over 12, and then minus pi over 12, and again all over 2. Okay. Alright, so from here, let's see what we can do. We'll leave this 2 sine as it is for now. I can add the fractions together at this point and get 6 pi over 12. Over 2, but I'm going to go ahead and write that as 2 over 1 because I know I'm going to multiply by the reciprocal here in just a moment. And cosine of 5 pi minus pi. The denominators are already the same, so I'll have 4 pi over 12 over 2 over 1. Alright. And so just writing that denominator over under the 2 helps me keep it straight when I go to divide by the reciprocal here in just a moment. And so when we do, here's what we get. 2 sine. And so I'll flip that over, and then when I do flip that over, I've got 6 pi over 24, which is pi over 4. Alright, and then that's going to be times the cosine of, flip that, and then that would be 4 pi over 24, which is going to be pi over 6. And from there we can get values off of our unit circle. I want the sine of pi over 4. Sine of pi over 4 is going to be square root of 2 over 2. And I need the cosine of pi over 6. Cosine of pi over 6 is square root of 3 over 2. And if we simplify this down, we can, and come up with the answer. These two will cancel out, and then that's going to be square root of 6 over 2. Alright. And so that's it.